classes,
Yeah, this is math classes.
It's
math
teacher.
No, wait, come back. I'm science students.
Yeah, I'm supposed to have a math class with Jones,
At,
but I got lost.
at 10 or 11? Is it
Right
10?
now. Yeah. Right.
I can give her a call. I don't have the timetable. Let's
I
see.
do.
You do? Well,
Just come in something.
yeah, what room does it say you're supposed to be in?
Yeah, I'm gonna check that real quick.
Is this all the science students? Because it might be the other room in the main building. Because do you need to use this room? Is it all of you?
No, it's just my room.
Also, B or the A room.
Don't say 18, I'm like 18.
Yeah, that's fine.
我是吧？今年18岁。
You're in her class.
今年
Yeah, fine.
Oh, yeah, we do.
Yeah, that's right.
今年是
No, I just thought that it was biomass. Like, I thought it was all together.
No way.
I'll have a cocktail, okay?
Why?
No problem.
Can we listen together?
Okay. Okay. These look nice.
Are you sure?
They look nice. I don't know, €2?
Maybe. I don't know.
Did you buy it?
Yeah, but I don't remember.
Ah, okay. You have too much money, yeah?
No, I don't have the memory.
It's racist of mine in the class.
He is?
No,
Really?
poor student. I'm so poor.
He's not from China, he's from Iran.
He's the richest.
No,
Yes,
He's the richest.
Doesn't look like it.
Yeah, I'm very poor.
He doesn't look like it.
The rich always don't like it.
Ah, I see, yeah. Like Steve Jobs. Yeah.
This doesn't work well.
Yeah, it's very good, yeah. Alright, we'll continue now. So if you write this down, force. Right. So this lesson now is not too difficult, especially compared to what we were just doing in the kinematics. Yeah. Okay, let's start then. We all understand the word force. So what's another word for force? Or how can we describe force?
Power.
Like power, like a push. Yeah. So we kind of understand that if it's bigger, it means more is being done. But what exactly is force then? Not this. Not this. Yeah, not this. Okay, so in physics, force is what changes the motion of an object. So, for example, if you have something just moving along like this, and it suddenly changes, force is the thing that makes it change its motion. So, force is what changes the motion of an object. That is, force will change either the direction or the speed. So if the speed or the direction changes, or both, then there's a force on it. Okay, so this was moving east, and now it moves north. So there was a force on it. Or it was going slow, and now fast. There's a force on it. In other words, force causes... Oh yeah, so for the simple definition, it's just this, but just to explain it a bit more. In other words, force causes an object to accelerate. Okay, so this would be the key definition for the exam. So I think I'd like you just to write this part down.
can resistance be force? Because sometimes like just move and then it has a resistance and then you change direction.
You see resistance like a resistance force?
Yeah, it's a resistance in force.
Anything that causes a change in direction is a force. Yeah.
And how does the force act if the force has negative value? Is there a negative value for?
Yeah, so to be more precise, force is actually a vector. So it could be negative. Negative would just mean acts in the opposite direction.
Oh. Okay.
Yeah. So force is a vector. Yeah. Although, so you don't need the next part. Although force can have other effects. So force can also change the temperature or the shape of an object, not just the speed or the direction. So, you know, if you take something, and if I do this, then I've changed the shape of it with a force. So it's not only speed and direction, but really, later we'll actually understand that changing the shape is kind of like changing the speed and direction, but we'll do that later. Anyway, it's true to say that if an object is accelerating, then a force is being applied. That's the key idea here. If something is accelerating, then there's a force on it. That's critical. And also, as we were saying, force is a vector. So I think I would like you to make some note of this, that if it's accelerating, there's a force, definitely. So you could even write acceleration means a force is present, or there's a force or something. Can you make some note like this, please? You have this? It's good, by the way.
You want more?
Good.
You want more?
No. I'll be good. Huh?
You reach.
Okay, I'm good. I'll stand by a few hours.
You're too kind. Thank you. Okay. So, how do we measure force? I'm sure somebody knows the unit here for force. Newton, yeah. Force is measured in newtons, represented by N. So, this is something I've seen in the exam a couple of times. What is a newton? Like the definition of a newton. Does anybody know the definition of a newton of force? Does anyone know this one?
N equal M.
Yeah, but as a sentence, like how would you say what 1 newton is? 1 newton of force is, or... But without actually... Yeah, that's more like Newton's formula rather than the definition of a newton. It comes from the formula. So we say a newton of force is the amount of force required to accelerate a 1 kilogram mass by 1 meter per second squared. So if 1 kilogram has an acceleration of 1 meter per second squared, then we say there is 1 newton of force. Yeah. Oh, did I have a grammar mistake here? Yeah. A newton of force is the amount of force required to accelerate. Yeah, not accelerated. No D at the end there. Got that? Yeah. Has anyone seen this definition before? You've seen this one before? You haven't seen this before? This is new? Yeah? You've seen this before? Let's continue. So, So you need to learn this off. It could be in the exam. I've seen it a couple of times in the exam actually. It's not too difficult. Anyways, what is the relationship between force and acceleration? Well, this is what's called, which a couple of people have said already, Newton's second law. Newton's second law says that simply force is equal to mass multiplied acceleration. So, if you think about it, that makes sense because we were saying a moment ago that 1 kilogram of 1 meter per second squared acceleration makes 1 Newton then. So this is Newton's second law. In a different lesson we'll look at the 3 laws, but just for this lesson we're looking at Newton's second law. Where F is the force, M is the mass, and A is the acceleration. Now what I've not made perfectly clear yet is that this F here is the total force. So if there's like many forces acting on it, the F is the total force then. Which I didn't say because it seems pretty obvious. You want to combine them all into one. In fact, you can state Newton's second law in other ways too. For now we'll use this definition. But I do wonder if anyone knows another way to state Newton's second law. If you think back to your high school, if you've done it. I mean, this is the simplest way to state Newton's second law, F equals ma. But there is another way to state it. Anyone know? Monica, what do you think? Another way to state it, I'll give you a clue. It has the word rate in it.
What is it?
Rate, R-A-T-E.
Or can I say the production of mass and...
That's the same thing as this, not this. That's the one. Do you remember this definition? Yeah, we'll do that one in a different lesson then, but there's other ways to state this. Okay, so F equals ma. Interestingly, if you use this formula, you have another unit for Newton. Because remember we said in the first lesson, the units on the left must equal the units on the right. Now what's the units on the left here? Newton, N, yeah. And the units on the right? Yeah, kilogram meters per second squared. So this means a Newton is the same as a kilogram meter per second squared. That they're the same units really. And in the very first lesson when I asked you what is the base unit, the 7 base units, I'm sure a couple of people thought Newton was a base unit. But it's not a base unit because you can write it using kilograms, meters and seconds. So it seems like it should be a basic unit, but actually it's not a basic unit, it's not a fundamental unit, it's a derived unit. It comes from the other 7. Yeah? So I think it is worth noting that 1 Newton is also 1 kilogram meter per second squared, if you can write that down. Yeah, you have that. 1 Newton equals 1 kilogram meter per second squared, yeah. It doesn't matter for the exam if you use newtons or kilogram meters per second squared. Usually just use newtons, it's easier. Okay. Let's see. So let's try this one here. A 45, what's the funny? 45? Yeah, I like it. Is that too big or too small? But you don't know how old this girl is. She could be like 6 or something. Depends on the age and nationality. Yes. A 45 kilogram child starts to run from rest with acceleration of 2. What is the force? 90. Just m multiply a. So that means there were 90 newtons of force required to accelerate by 2 here. So that's a simple one to get started. Right, so here is a harder one now. You see a barista slide a cup of coffee along a table. The coffee is initially at rest, and you estimate it leaves his hand at 30 centimeters per second. And he seems to be in contact with the cup for 1 second. And you estimate the mass to be 500 grams. What was the force in the person's hand? So what's happening here is you have a cup of coffee on the table, and the person slides it over to you. So it starts at rest, and then its speed increases to 30 centimeters a second. And this was because for 1 second, his hand pushed it. So let's just draw this and try and work out together how to do this. So what is the mass here? 0.5 kg. And then for 1 second, it went from rest to a speed of 0.3 meters per second. So because it changed its speed from rest to 0.3, there must have been a force. And we know there is a force because it comes from the person's hand pushing it. So the question is, what is that force? Well, let's try and calculate it. So Newton says F equals ma. Do we know the m? Yeah. Do we know the a? No, but we could know it. How can we continue? Yeah, how? Yeah, using UVATS. 0, 0.3 and 1. Yeah? So V equals U plus AT. So it looks like A is just 0.3. So if I put that in there, I'll get 0.15 newtons as the answer then. So you realise the difficulty was just understanding the problem, not actually the calculation, which is kind of common here. So if you can write this example down, I don't know if you want to write the question down or if you just want to draw it, but this is the answer here anyways. If you wanted to write the question down, you can get it from the video later.
Sure. Do we have to memorize the formula of UVATS?
No, you get a formula book. Yeah. Alright, do you have this?
Yeah.
You need a second, Jerry? That's okay.
No, I don't need it.
It's okay? Yeah. I haven't done one like this. I'll just make up an example here. I don't think it'll be a problem. So look, just to be clear about this, if there's a force this way of 200 newtons and a force this way of 50 newtons, and let's say this is, 20 kilograms, then this is like just 150 this way. Yeah? And this is 20. So the acceleration we can get from this formula. Isn't that it? Yeah? 150 over 20, which is 7.5? 7.5 meters per second squared. Like that. So you just add them together, and of course if the 50 was here, then it'd be 250. Yeah? Okay, so that's just another simple example. So here you could just say find A, and this is the question, and this is the answer here. Okay, so if you can write this one down as well. Okay, you have that one? Yeah. So it's not too difficult here. Just looking at the questions I have for you, the first few are very easy, but the last two get much harder, and the last one here is actually quite hard. So I think if you try these now, what will probably happen is you'll get the first few done very quickly, but you'll need to think a lot about the last two. Okay. By the way, actually, were there any problems with the equation of motion? No, the last one was okay in this? With the two cars? Huh? No, it wasn't okay? Or was it okay? Ah, so why didn't you tell me anything earlier? You can ask, we can do it next week if you want, next Friday. Remember. Okay, so let's have a look at these. We can try it for a few minutes. If you get them finished, I suppose you could have a start on the next lesson, but let's see how you get on.
Thank you.
That's 101.9 grams in the first question. Okay. You can try these now. Yeah? A physicist. You got my joke. Yeah. I did that on purpose. The answer is a Newton.
2 we need to use MGH?
No.
What is KM? The number 4.
I think you know. What does K stand for? Kilo. And N? KM?
Oh. Do you still the kilogram times kilogram meter per second squared?
You see, I would change all these into meters, seconds, and newtons. So, I know 2 kilometers per second. I would change that into 2,000 meters per second. I would change the 200 milliseconds into 0.2 seconds, and the 1 kilonewton into 1,000 newtons.
Oh.
I mean, you don't have to, but I think it's easier this way. What's up?
No, just
No?
the direction forward.
Are you doing the tugboats?
Yeah.
Okay guys, just before we go, there's one more example I want to do, okay, because I think Chrissy, we were talking about one of the questions where you have to change the units. I think it's a good, safe strategy to change the units back to meters and seconds. So, as an example, I want to do this one. A 1,200 kilogram car is travelling at 100 kilometers per hour. So the first thing we need to do is to change that into meters per second. So we have our car, 1200 kilograms, and what did I say, 100 kilometers? Yeah. Okay, so 100 kilometers per hour is 100,000 meters per 3,600 seconds. Can someone tell me 1,000 over 36?
27.78.
What is it?
27.78.
Okay. Now, what happens is the car was going along and then it's at rest. It brakes. So which way is the force acting? To the left, because this force is slowing the car down from this to 0. So we want to know how big this force is. So F. So this is an example of a minus. F equals ma, which equals 1200 a. So now we need the a. Okay, well let's get that. This is the u. The v is 0. The a is what we want. The t we don't know. And in the question I tell you, it takes 100 meters to do this. Yeah, I think it'd be the v squared one, won't it? V squared equals u squared plus 2as. So s is minus 27.78 squared over 200. Oh, so what am I saying? It's the right number, but I wrote the wrong letter. 200a, because we know the s. Sorry. So yeah, what's the a there? Is that all? I was expecting it to be bigger. 0. I'm concerned about the 0 point. Okay, if that's what it is, that's what it is. I just would have thought it should be having a bigger deceleration. And that's still small. Are you typing in 27.78 squared over 200?
Yes.
Okay. Is the no problem. Is that the 3.85?
3.86.
So that's the acceleration now, and it's minus because it's decelerating. So what is that now if we multiply then? 4632 newtons, or minus 4.63 kilonewtons. And the minus is to tell us the direction to the left. It's reducing its speed, decelerating. Okay, is that one okay? Yeah. Now, just before you go, how are these questions going? Monica, how many do you have done? And KJ?
5.
You're on 5? 6, good, okay. Chrissy?
5.
Okay, so most people on 5 then? Bruce, you're on 5? Okay. So, try to get these finished. It's always homework. There's always homework. I always want you to finish. But I mean, you have the whole weekend to do 2 questions for me. So you still have plenty of time to enjoy culture nights. Okay. We'll finish there. So